been a little bit behind, but certainly not last but not least by any stretch of imagination is RAP. Continuing kind of our networking theme here with some interesting uh, wireless stuff. So RAP team, if you could, apologies for getting you started a little bit late, but I, for those who can stay on, I definitely want to hear the RAP discussion.
Yeah, thank you for the opportunity. My name is Ying Wang from Stevens Institute of Technology, and my co-PI is Dr. Juntao Chen from Fordham University. So the RAP is Programmable Wireless Infrastructure program access platform. So the main part of it is actually comes from as a researcher, especially when we do cross-campus research, we need the flexibility, like we can onboard new devices. We need a new type of data connection to the infrastructure. We need to change a little bit. Like for example, we want to load the ORAN node into the campus infrastructure, but then on the other side, on the campus infrastructure, there is policy that need to be compliant with. There is security concerns. So how can we make this converge? Like how can we make the two sides requirements in both meet both two sides of the requirements? So we have three thrusts for the RAP. The first one is to provide the programmable wireless infrastructure. So this is like I think the previous team already talked about ORAN. So we use the combines the open Wi-Fi and also applied the ORAN design into the open Wi-Fi structure so that we can provide this slice-based access control for dynamic VLANs, for federated identity, and for multi-campus research. And then the second thrust was more focused on the assurance side, how we can provide this lighter weighted assurance and do the runtime validation. So we use formal verification, guided fuzzing to accelerate the thorough, rigorous validation system assurance, and also use the runtime anomaly detection for IT-facing dashboards. And then the third thrust will focus more of a usability-centered security. So the researchers from different domains, we will collaborate with them to build the interface so that the scientists can express their goals, like their goals for low latency, what kind of security collaboration that they needed, and then that will be mapped into a verifiable policy compliant configuration. So our plan is to first develop and deploy RAP at Stevens and Fordham University, and then we will work across we have a team of the researchers that we work with. They are from genomics, robotics, neuroscience, AI, aerospace, and quantum computing. So the output will include the open source toolkits and data set, the training resources to provide the replicable and sustainable model. So on the sharing part, the data sharing part, so first is the generated data. So for generated data, we will have different types of data. It was more from fuzzing and like the first one is the formal guided fuzzing test result. So that include a lot of the attack traces, a lot of the log files that generate from the fuzz testing, and also this is it's not an ORAN test set. It should be a RAP test set, data set that will have all kinds of slice definition, runtime anomalies, and the protocol deliverables. Also, we'll have the usability metrics that from the researcher interactions, like in the third thrust, to record their behaviors, their thoughts, their feedback, and then integrate it into the designs. So the format of data will be a more structured side on the JSON, CSV, or YAML file for interoperability, and then we'll also have a lot of raw data that generated for the log file from the fuzz testing. And then we'll have the metadata aligned with the IEEE standard for discoverability. So we already have the GitHub repository that we started to put our existing data and then generate a lot of new data uploaded there. And for reusability, we are looking to deliver the formal verification configuration, the network anomaly detection model, and also policy compliant benchmark that we verified in Stevens and Fordham University, and also like between all the traffic between us. And also we like the last meeting that the OSDF and the NDP introduction was really helpful. We hope to have more opportunity to interact with them in our data plan. Yeah, thank you.
Fantastic. Right. So yeah, lots of good stuff here. You know, and notice so I know we ran over a little bit of time. Apologies for that. I'll wrap us up kind of quick here, but this is really good stuff. You can see kind of the diversity of data challenges we have from medical data to networking data. You know, not all the projects directly interact, but I think there is some good overlap in a way. You know, I think there's some interesting overlap between the last two projects in particular. There's some stuff with there's aspects of wireless and Open RAN on both these guys that I think is a positive overlap in a way. And looking forward to that. Some really interesting at the beginning, some really interesting stuff on the more data sensitivity, where I think the later piece we're more looking at data fuzzing and testing and operational pieces.